Hey there, hey team. So, ooh, that's my recording software. We're gonna get to the second part of your question now. Now this one actually is a little bit easier. Without this table, it is near impossible. So don't feel discouraged at all about that. You definitely need this table over here to the right, B16. You really do need this. So I don't know if you need help with 12 through 15, but we can go over it very quickly. Let me zoom in here. So oxidation, right? We talked about in the last video. It increases the thickness, and I'll pick a new color. What color do you like? I'm gonna pick orange. So let's do oxidation, right? Oxidation. Now we talked about oxidation before was when a charge increased, right? And if you remember, that happened with it losing electrons in the products of the equation, right? So we know oxidation is going to be either B or D, but it's the place of where the electrons are taken from, and it's the right side when it's oxidation. So 12 would be B. Now, these here, biggest advantage and disadvantage, I'm not exactly sure what they want there, but I mean, I think obviously it's going to be between A or C, and we can decide an advantage would be no pollutants, right? Explosions are usually not an advantage when dealing in chemistry. Explosive hydrogen fuel, I think that would definitely be a disadvantage. See? And reduction, right, is when the left side you actually are going from a I just had a brain fart. Reduction is when you actually lose a positive charge, so you're gaining electrons in the reactants, so therefore it should be D, right? D. Oh, that's horrible. I'm going to do that for you. D, better. So yeah, so just some basic stuff there. Just try to remember oxidation and reduction. Just kind of remember what is which so you can get that done. Down here though, this half cell stuff, this is where you definitely need this chart. Because it looks complicated, but if you just look at this graph over here, it's actually incredibly easy. So right here it says, given the half cells, determine the anode and the cathode and find the electrical potential for the voltaic cell. So if we look here, the cathode is positive. Let me check my notes, because I remember I wrote it down, because I also sometimes forget. I believe the cathode is negative. Positive. I'm so sorry. Yep. The anode is actually negative. So just go ahead and annotate that. The anode is going to be your negative value, and the cathode is going to be your positive value. That's something important to know. And I don't longer like this orange. It's actually bugging me. It's a little too crazy orange. So let's go red. Anode, cathode. Anode's negative, cathode positive. So now that we have this here, we need to figure out what it's asking for. So it's given our half cell. Now we have the Mg with a positive 2 with an Mg with no charge. So if you go over this chart here, we need to find the half reaction of Mg right here, right there. See that? Boom, right there. So we can write that out. It is Mg2. It is actually being reduced, right? It's actually losing it's actually gaining 2 electrons to become Mg with no charge. And as we see here, that value is 2.37, negative 2.37. And because it's negative, we know it's our anode, right? So the anode in this would definitely be Mg. And now we can determine our cathode. So we see chlorine, right? See chlorine 2, and it leads to a chlorine negative. Now, if we can assume there's going to be a cathode and an anode, we need a positive one to this, right? So we can look in the right column maybe, and there it is right there. Cl2 turns to Cl negative. So we get Cl2 comes into, oh, I forgot pause it plus first. I'm so sorry, because this is now a I didn't do that. Cl2 plus 2 electrons, right? 2 electrons creates Cl with a negative 1. And the charge on that is 1.36. positive, right? I'll just annotate that, just to be sure. And so we know our cathode is Cl2. Oops. Is Cl2. Ooh, sorry. Plus 2 electrons. And so now here it gives you a little equation. The energy level of the cell is just the cathode minus the anode. So we take the values, right? 1.36 minus 2.37. I didn't have my calculator up, but I think it's going to be negative 0.99, I think. Around there. Let's just do that. 1.36 minus 2.37. Yeah, I see. I knew it was one way or the other. Actually, let's just write that down. So our cathode is this here, 1.36 minus our anode. Now I'm curious here, because the energy level of our anode is a negative, but it has a minus sign here. So I'm annotating that. You see here, I have that minus from the equation here, but the actual number here is a negative. So I put it in parentheses because if all the simple rules of math, we have to carry that negative sign to this and make it a positive 2.37. So make that 1.36 plus 2.37, which will equal 3.3. I'm sorry, 3.73. I believe, off the top of my head. And I'll just do calculator because I am not a calculator myself. Yep, 3.73. It should be our energy level. It seems like they want the whole equation there, so you can just write out the equation. But yeah, that is pretty much it, how to do those. These ones are a lot easier than you would think, but you really do need this chart. I don't know if you have it. I hope Ms. Morgan got it to you, but I will also include it in my email along with this video. So I hope this helps. I know there's a few more of these on there. I want you to try them and let me know how you do, if it makes sense. Hopefully you have access to the key as well, because to tell you the truth, I hope I am also doing them correctly, because I myself don't have the key here with me. This is just basically off what I remember and how to do them. So let me know if this helps, and if you need any more help, just call me any time of day, man. I'm here 24/7 for you guys. So have a great day. Oh, good Lord. Have a good day, Mr. Pendawala, and stay safe.